Today's lesson is 7.1, Finding Square Roots. A square root of a number is a number that, when multiplied by itself, equals the given number. Every positive number has a positive and a negative square root. A perfect square is a number with integers as its roots. The symbol is called a radical sign. It is used to represent a square root. The number under the radical sign is called the radicand. So you'll see in the first box we have the square root of 16. This is asking for the positive square root. We have the negative square root of 16 is equal to the negative square root of 16, or negative 4. And when we want both square roots, we say positive and negative square roots of 16 would be positive or negative 4. Now let's talk about perfect squares. So perfect squares are numbers that, when we multiply by itself, are going to get nice, easy numbers. And we should be memorizing at least the first 15 perfect squares. So I'm going to write these up here, and I want you to take a minute to try to fill them in. Now you can see that I've written the first 15 perfect squares here for you. The more of these that you have memorized, the easier it's going to be when you go to do your work. You'll be doing less calculations, trying to figure out less problems. The first 15 is really essential. From 16 to 20 is a little bit more optional. So here those are. So 1 times 1 is 1, 2 times 2 is 4, 5 times 5 is 25, so on and so forth. So you can take a minute to write those down. Now we need to find the two square roots of the number. So we know that 6 times 6 makes 36. So one square root is 6. Now, another integer that when squared makes 36 is negative 6, because we know that when we multiply a negative times a negative, we get a positive answer. Go ahead and answer 10, 2, and 3 right now on your own. You should have found that the two square roots of 100 are 10 and negative 10. The two square roots of 121 are 11 and negative 11. Now we need to find the square root or roots as we're directed by the instructions here. So the negative square root of 1, well, 1 times 1 makes 1, but we need the negative. So our answer will be negative 1 because it's specifically asking for the negative square root. Here you can see that number 5 is asking for both the positive and negative square roots. Now you're probably thinking, well, this one looks a little bit more complicated. When we have a fraction, it's like taking the square root of the numerator and the square root of the denominator. The square root of 4 is 2, and the square root of 25 is 5. So the answer here is positive or negative 2/5. Now, with number 6, we need the square root of 12.25. Now, there's a few ways to think about this. We need a number when multiplied by itself will end in 5. Well, we know 1 times 1 is 1, 2 times 2 is 3, or 2 times 2 is 4, 3 times 3 is 9. We need to find one that will end in 5. Well, we know that 5 times 5 makes 25. So we know that whatever our number is needs to end in a 5. When we're talking about our perfect squares, we know that 1 squared is 1, 2 squared is 2, 3 squared is 9, 4 squared is 16. So here we know that 12.25 comes between 9 and 16. So the square root must be between 3 and 4. So since we know it ends in a 5 and we know it has to be between 3 and 4, let's try 3.5. So when we multiply 3.5 times itself, we can see here that we're going to get an answer of 12.25. So the answer to number 6 is positive 3.5, since it's asking us for the positive square root here. Squaring a positive number and finding a square root are inverse operations. They are the opposite of each other. You can use this relationship to evaluate expressions and solve equations involving squares. So here we're going to simply work through to solve or evaluate the expression. Well, the square root of 25 is 5. This is like 3 times 5. So 12 minus 3 times the square root of 25, which is 5. We know that 3 times 5 is 15, so 12 minus 15 is negative 3. You go ahead and try number 8 and 9 on your own now. Now, some of you are probably thinking, well, she said that we could use the square root of the numerator and the square root of the denominator to help simplify fractions. And we don't know what the square root of 28 is or the square root of 7. But we do know that 28 over 7 can simplify to 4. So this is like the square root of 4 plus 2.4. The square root of 4 is 2, and 2 plus 2.4 is 4.4. Now remember to line up your decimals when you add and subtract. Now with number 9, we read up here that the square and the square root are inverse operations. So when we have both on the same number, they cancel each other out. And we're left with the number inside the radical sign. So this 4 stays. So 15 minus 4 equals 11. Now, if we need a little clarification on this, we could say that this is like 15 minus the square root of 4 squared. Well, the square root of 4 is 2, and we know that 2 squared is 4. So we can see that that explains or shows us how we can cancel the radical sign with the square. Now on number 10, the area of a circle is 2,826 square feet. Write and solve an equation to find the radius of the circle. If you remember back to earlier in the year, we know that the area of the circle is equal to pi times radius squared. Here we're told to use 3.14 for pi. The area we're given 2,826. Now we need to solve for r. So we can start by dividing by 3.14 on both sides. 2,826 divided by 3.14 is 900. So 900 equals r squared. Now in order to get r by itself, we can take the square root of r squared. So the square root of r squared and the square root of 900. Now remember, the square root and the square cancel and we're left with r. The square root of 900. Well, we know that the square root of 9 is 3. So 3 times 3 is 9, but we need the 2 zeros. So 30 times 30, we multiply our 3's, and we can add our 2 zeros. So r is equal to 30 feet.